So I originally thought of a good way to start this talk, but after the last talk, I really like this idea of quantifying something that we think is subjective as a way to start. Oh, yeah, don't squeeze this when you're talking. So the idea of quantifying something that's subjective, and you can get a sense of that from the title of my talk, Individually Experienced Temperatures in an Urban Neighborhood, a new approach to measuring heat exposure. And our experiences with heat are something that we think is subjective. When we're hot, we want to be somewhere that's cold. When we're cold, we want to be somewhere that's hot. But I wanted to quantify this to better understand how these kinds of things can vary across a landscape and in a city, and especially within a neighborhood. And this is something that I was interested in as an ecology major, where we like to measure things. And as someone interested in people too, I thought, why not measure something that's maybe a little bit subjective? So we'll see what happens. But in order to see why this type of question is important, we need to understand the urban heat island, which is this idea that cities are hotter than their surrounding suburban and rural environments. And this is a result of aspects of city design, like tall buildings and asphalt, which are really good at holding heat, especially compared to trees and water and things that are good at dissipating heat, which we tend to find outside of cities. And so cities are hot, but they're also spatially heterogeneous, so that not all parts of the cities look the same and have the same things there. So if you can imagine you're Batman standing here in Government Center on a hot day, or maybe you're Batman here standing on Marsh Plaza on a hot day, where do you think you'll be hotter? Is it not a theoretical question? Yeah.
Government Center?
Why?
So many buildings.
There's so many buildings in Government Center, that's right. There's buildings and asphalt, and BU campus, there's a nice breeze and the Charles River and trees. And so yes, the heat will be different. And so while cities are hot, heat is not evenly distributed throughout cities. And this matters because heat-related mortality varies spatially, varies by neighborhood. And this is a map of Philadelphia. The little white plus signs are excess mortality on hot days, and these are different by neighborhood. And so if we know that there's intra-city variation that affects neighborhoods differently, what about the people that live in those neighborhoods? Or is there intra-neighborhood variation in the way that individuals experience heat? And this type of question challenges the assumption that people living in the same urban neighborhood experience the same thermal environment. And we have an assumption like this because when we measure temperatures, we do so spatially. We use satellite imagery or stationary sensors that tell us how hot different areas of the city are. And so it's a quick jump to say, well, then if you live in that place, those are the temperatures you're going to experience. And so my question was, well, do people living in the same neighborhood experience the same temperatures? And our null hypothesis would be yes, because that's generally what null hypotheses are. But our adjusted hypothesis would be that no, there's probably other variables, oh my God, other variables besides where you live that determine the temperatures you experience. And so right now we're all in the same room experiencing the same temperatures, but unless your roommate is here, well, like my roommate, is here. So unless everybody's roommate is here or the people you live with, they're probably experiencing different temperatures from you right now. So it's not necessarily just the place you live, but other things like what you do and who you are that might determine what you're experiencing. And so some of the things that we see in the literature are attributes about people, like where they work and live, and indoor-outdoor resources like air conditioning, distance to parks, race, class, gender, age, occupation, and then other variables we don't see as much in the literature, behavioral things, preferences, lifestyles that could all go into the temperatures that people are experiencing. And so to answer this question, do people living in the same neighborhood experience the same temperatures? I recruited 23 people living in the same neighborhood to carry eye buttons, which I have here on my belt, and another one in my pocket, which you wouldn't do, but they're like this big, to measure temperatures for a single week. And these recorded air temperature every 5 minutes for a week in July. I also collected demographic information from my participants. They filled out daily surveys. I conducted interviews with them, and they drew heat maps to demonstrate their understanding of heat in their neighborhood and how they used space to deal with it. I conducted a field ethnography of the neighborhood during the summer to understand how people used space to stay cool. And luckily for me, but not for everyone else, there was a heat wave during the study week, which happened during the first 3 days, which I'll be comparing to a reference period, which happened the following 3 days. So again, good for me. even though it was so hot I ended up just sleeping instead of doing observations those days. So I chose Boston South End as a neighborhood to study, which is here on the map. And I'm glad that Will had us talk here earlier so we can get a sense of what Boston looks like. Oh my God, I think it just goes on its own. So the South End is a good neighborhood to study because it's very diverse. It's close to the urban core. It's gentrifying, which Will talked about, but in brief is a process of neighborhood change where middle and higher income folks move into an area, property values rise, new businesses come in, and the folks who are there originally are displaced. As one of my participants explained for the history of the South End, she said, the black people came in, and then the gay people came in, and now it's nice. Which is one narrative of how gentrification happens in a neighborhood like the South End. Importantly for me, it was close to campus, which you can see on the map here for reference. And if you remember where Bova's is, that's another good thing to have in the back of your mind. So this is an example of what the data look like. The black line is outdoor ambient temperatures for July 18th. It's just a sample. The other three lines are individually experienced temperatures, which I'll call IETs. And you can see these explanations they have of each of the lines, and you can make up your own stories to see why they would look like that. We can even see for our blue friend when she went to work at 9 and came home at 5, which is really cool. So these work to measure air temperature that people are experiencing. And to get a better sense of how these compare to the neighborhood, because that's our question after all, I have this graph of box plots. And these boxes describe the spread of temperatures that people are experiencing. So the bigger the box, the greater the range you'll experience. The smaller the box, the smaller the range. The higher the box, the hotter it is. You'll get a sense of it. And so these boxes describe the temperatures of Boston South End on the left. Yep, on the left, and airport right next to it during the heat wave. And so if everybody in the neighborhood experienced the same temperatures, then everybody's box would look something like these along this dotted black line I put conveniently here. But in fact, it's all over the place, which is crazy. And those little blue triangles show that there's a significant difference between that person's box and the outdoor temperatures. And so this is 20 out of 23 people that experienced something different during the heat wave from the outdoor conditions. We can also see, so we can say that IETs are widely variable, especially during a heat wave. And we can also pick out people who maybe weren't so different. So here's Nina and Warren, who spent a lot of their time outside. And there are two people whose temperatures were not different from outdoor conditions. And we can say maybe that's explained by the fact that they were outside for so long. And we can see Mackenzie here, who spent very little time outside, and so that is why she was so cold. And this is, first of all, really, really cool. But there's a lot more to this story. So this graph shows the difference between the heat wave period and the reference period. The taller the black box, the more significant the difference. So big black box, you were a lot warmer during the heat wave than the reference period. Gray box is non-significant difference, and if it's negative, that means the reverse, that you were actually warmer after the heat, during the reference period compared to the heat wave. And so about half of the sample here was warmer during the heat wave compared to the reference period significantly, which I guess you would kind of expect, although you might expect everybody to be warmer. So this is interesting. And we can understand this better if we find Nina and Warren again. These were the two people that spent a lot of time outside, but their boxes now are very different from each other. And that's because Warren had AC and Nina didn't. Okay, so how this works is that Warren spends a lot of time outside, but every day he goes home to air conditioning. So his indoor temperature doesn't change during the study week, but his outdoor temperature does. So when it gets cooler outside, he gets cooler, which we can see here by this black box. For Nina, she didn't have air conditioning, and when the heat wave ended, her indoor temperatures stayed warm because her building held on to heat better than, while Warren had the air conditioning to keep things cool. And so even though her outdoor temperatures lowered, her indoor temperatures kept Nina's temperature experience warm. And so so not necessarily just from the time spent outside, but things like resources also matter for how people experience temperatures. Interestingly enough, here's Mackenzie, who looks a lot like Nina, even though she spent a lot of time inside. And that's because she spent so much time inside that the heat wave didn't really affect her. And so there's a lot of dimensionality to how people are experiencing temperatures and what matters for their temperature experiences, especially if we're concerned about extreme heat exposure. And so from this graph, we can conclude that IETs are only partially determined by outdoor temperatures. To make this even more complicated, which is what this is all about. Here's some group differences in IATs during the heat wave. And so we can see that men are significantly warmer than women. Participants identified as Black or African American were warmer than women, white participants. Those living in subsidized housing warmer than those living in private housing. And these differences show that there's variability between social groups. And they also happen during the day when people are active, moving around and using space, which means that there are social mechanisms and behaviors that matter for how people use space and experience temperatures. Also, if you were paying attention, my sample size doesn't add up. I took out Nina from here. I cheated. And that's okay because it's for a presentation. And I took her out because she was a woman, she was white, and she lived in private housing, and she was very warm. So none of her group characteristics would have predicted the temperatures that she experienced. Which means that while group is important, other things also matter. Here's a picture of Titus Sparrow Park in the South End. And we can see that people who live in the same place, like the South End, and use the same space, like this park, may do so differently. Here are two people sitting in the shade, and here's somebody sunbathing. Nina did sunbathe. I saw her a few times during the summer sunbathing. This isn't her, but this is a good example of how people use space differently. And these can be because of individual behavior framed by the social context of the neighborhood, maybe because it's a gentrifying place, maybe because of what's expected of you by your peers, or maybe because there's Batman there. Did anybody see Batman? And so behavior matters, group matters, all these things matter. In temperature experiences, even within an urban neighborhood. And so as a review, I found that temperature experiences are variable. They're only partially determined by outdoor temperatures. They vary between social groups, and they're partially determined by individual behaviors. In other words, everything matters. But really, it's about the spaces that people actually use. And place where somebody lives matters, not necessarily because of the temperatures that they're exposed to in those places, but because of the social context that determines how their behaviors and their social group characteristics are manifested in the spaces that they get to use and have access to. And I think that IETs and this type of method of maybe quantifying something subjective like temperature experience is important because it can help us integrate individual, group, and neighborhood level attributes to better understand how people are exposed to heat so that we can help mitigate heat where it's greatest in cities and help people have access to cooling resources that are generally excluded from them. So I'd like to thank everybody, the Honors College, my advisors, some of whom are here, Europe, and my participants, and the good people of Boston South End. So thank you very much. Do I have time for any questions? Cool.
What has you carrying around the I button taught you about your heat exposure?
Oh, gee. I really wish I had carried it around during the study week so that I could have compared it to my participants, but I didn't. I think what the cool part was for my participants is that when they were carrying around the I buttons, or even once they found out about the study, they thought a little bit more about space, and they would tell me when I met with them afterwards, like, yeah, I really noticed that it was a lot cooler on this street than on this street, or like that my bedroom was a lot warmer than my living room, and I just never paid attention to it before. And so I think that making something invisible become visible like that is a really cool process, and that I think for heat exposure, it's one of those hazards in cities that people don't necessarily pay a lot of attention to, especially if people assume that they have access to air conditioning. And we haven't had any power outages in a long time for major heat waves, maybe a decade or so. And so for people to become aware of heat conditions, I think is important, especially as we're expecting increasing climate change, more and more cities, that heat's an important thing. People need to think about what their exposure is like, especially if there is a power outage during a heat wave, and we all of a sudden need to find places that are cool. If you're used to going home into your air conditioning, and now that's not an option for you, what other resources are available for people who live in cities to protect themselves from heat-related illness and mortality? So to answer your question, it's very cool. You should carry one and think about your temperatures as well. So that's probably it. Yeah. Cool. Thank you very much, everybody.